Alright, so I'm going to go through a couple examples just for finding the derivatives. And again, when we see this word derivative, just a reminder that that means slope. So you're just thinking in your head, find the slope of f of x equals x squared plus 2. Just very quickly, if we kind of graph this, right, x squared plus 2 is going to be a parabola. And so we graph this, and you can see the slope is actually always changing. It's not like a linear function like that would always have the same slope everywhere. But for y equals x squared plus 2, we can see everywhere where we would draw that kind of tangent line, it just keeps changing and changing. And so what happens is when we find a derivative of a curve like this, the derivative is going to have an x in it, so it's always going to be able to change. It's going to have a variable. And we'll see that when we get the answer. So when we want to find the derivative, we're going to kind of go to that definition of the derivative right now. And it's the limit as h approaches 0 of f of x plus h minus f of x divided by h. And then to figure out what is f of x plus h, we take that x plus h and we plug it in anywhere where we see an x, right? So when we plug that in, we basically get this is the limit as h approaches 0. Okay, it was x squared plus 2, so it's going to change to x plus h squared plus 2. Then minus f of x. F of x is this whole thing. So minus x squared plus 2. And then all divided by h. Alright, so we're going to rewrite this. The limit as h approaches 0. I'm going to expand out x plus h, like FOIL it out. We're going to get x squared plus 2xh plus h squared plus 2. And then we're going to subtract. We're going to distribute the negatives, so minus x squared minus 2 all divided by h. And notice that right now if you tried to plug in h0 for h, if you had tried to plug it in, you're going to get some number divided by 0, and we'll actually end up getting 0 over 0. And that means we have to keep factoring. So now we can kind of look at what we can cancel out. We can cancel x squared and minus x squared and plus 2 and minus 2. And so now we have the limit as h approaches 0 of 2xh plus h squared divided by h. And if you notice from the top, the numerator, we can factor out an h. I'm going to write it over here. So it's the limit as h approaches 0 of, we factor out that h, 2x plus h. And then we can simplify, and so we can divide out that h. And that leaves us with the limit as h approaches 0 of 2x plus h. And now here we can actually go ahead and we can plug in that 0 for h without having a 0 over 0 case. So that gives us 2x plus 0 or just 2x. And so that's the answer for our derivative. So we kind of say that dy dx, which is our symbol for the derivative, is equal to 2x. And so that means that, you know, if we come back over here, anywhere where we knew what x was, like let's say we knew that x was 1, if x was equal to 1, then the slope at that point would be 2 times 1, or 2. But if x was like negative 3, then the slope where it was negative 3, where x was negative 3, the slope would be 2 times negative 3 would be negative 6. So the slope is always changing, and it's changing at a rate of 2x. Alright, let's do one a little bit trickier example. This one says find f prime of 3. We see that f prime, and immediately that f prime tells me it's a derivative. And then, so the f prime says it's a derivative, and then the 3, we know, just like how you had a f prime of x, or f of x. There we go. So that 3 is where the x is. So this is the derivative at x equals 3, or when x is equal to 3. So basically we're going to find the derivative first, and then we'll plug in x equals 3. So we're going to do the limit as h approaches 0 of f of x plus h minus f of x divided by h. And same thing as before, we're going to take this x plus h, we're going to plug it in everywhere where we see an x. So I like to write this with a bracket, the limit as h approaches 0 of x plus h squared plus 3 times x plus h plus 4 minus, and then just f of x would be x squared plus 3x plus 4. Make sure that you put, when you plug in f of x, make sure you put this parentheses, because you're going to have to distribute that negative. All divided by h. Now we're just going to start simplifying. So I'm going to expand, FOIL that out, x squared plus 2xh plus h squared, distribute the 3, plus 3x plus 3h plus 4, and then we distribute this negative, minus x squared minus 3x minus 4, and all of that is divided by h. Okay, now we can start simplifying. X squared and x squared plus 3x minus 3x plus 4 minus 4, and we end up with the limit as h approaches 0 of 2xh plus h squared plus 3h, all divided by h. And then from here we can factor out an h. So we get the limit as h approaches 0 of h times 2x plus h plus 3 divided by h. Then we can simplify, and that leaves us with the limit as h approaches 0 of 2x plus h plus 3. Then we plug in 0, and so that tells us that this limit would be equal to 2x plus 0 plus 3, or just 2x plus 3. And so this right here, it's not our answer, but what this is this is f prime of x, or you could have called it dy dx, or you could have called it y prime. But that's the answer. That's our derivative anywhere. So that's the derivative anywhere on that function. We didn't just want the derivative anywhere of this function, though. We wanted the derivative at x equals 3. So what we can then say is that f prime of 3, we just plug in 3 for x, and we get 2 times 3 plus 3, or f prime of 3 would be 6 plus 3 is equal to 9. So just to do a quick recap, okay, anywhere where if you see kind of f prime of x, that's kind of like saying the derivative, or we could think of that as slope, right? The derivative at any point on our function f of x. So it's basically, this is going to actually, f prime of x will actually also be a function. It will have an x in it. It doesn't have to have an x, it could be like a constant, it could have a 3, but it's going to be like, you know, y equals something. So f prime of x is going to basically be the derivative anywhere, the slope anywhere on f of x. And then if we have f prime of some number, right, and we could call that f prime of some c, but some constant number, that's going to be the derivative or the slope at one specific point, and that point would be when x is equal to whatever number you plug in. So, you know, this 2x plus 3, that's our f prime of x. Then we plug in 3, and 9 is the slope at x equals 3. So basically, if we come back to this x squared plus 3x plus 4, when x equals 3, the slope, or the derivative, right, dy dx, the slope of this function x squared plus 3x plus 4 is equal to 9. So hopefully that gives you kind of a little bit of an intro to these derivatives, and I'll see you guys in class tomorrow.